In this video, we are going to look at properties of logarithms. If you remember back to exponentials, we had about 9 different properties that went with exponentials. Log properties, there are 3. There are only 3 log properties. And this is going to be one of those cases where I'm going to tell you it's important you do not make up your own log properties, because that happens a lot. There are only these 3 properties that we're going to look at. The first one is the logarithm of a product. The logarithm of a product means if I'm taking the log base b of a product, x times y, that's the same thing as taking each of these individual logs. Log base b of x plus log base b of y. So that's one property. If I'm multiplying the argument, that's the same thing as adding each of the individual logs. And vice versa. Remember, you have to go backwards and forwards. If you see the log base b of x plus the log base b of y, that's the same thing as the log base b of the product of their arguments. When we add logs, we multiply their arguments. When we add logs, we multiply their arguments. Or when we're multiplying an argument, we're adding logs. That's the first property. Second property, very, very similar. It's just with quotients, with dividing. So for this one, the first property is log base b of x over y. That's just the log base b of x minus the log base b of y. Now, when I'm dividing within that argument, that's the same thing as subtracting logs. Again, backwards. That's the same thing as the log base b of x minus the log base b of y equals the log base b of x over y. You have to be able to go backwards and forwards. You will actually probably see the second one more than you will the first one, this second statement here. Being able to put that back together when we start condensing our logs. The third and final property is logarithm of a power. Logarithm of a power says log base b of x to the n. My argument has an exponent. My argument has an exponent. That is the same thing as that exponent times the log base b of x. So that exponent comes down in front. Again, vice versa. If you see n times the log base b of x, feel free to move that n up top as an exponent for your argument. Now, we can't have other operations that are taking place in here. If we're going to perform these properties, it has to be as a single log in a single situation or with the subtraction piece. So please do not make up your own rules for these. Now, I've got some examples that go along with each of these as well. So in the first one, I have the log of 6. I can break that one apart, and I can rewrite 6 as the log of 2 times 3. Okay. Argument has an exponent, multiplication, division. That's how we can break apart those arguments. So then, if I know the log of 2, which we'll end up working with the log of 2 a lot, and if I know the log of 3, I just take each of those individual logs and I add them together. So I'll end up telling you what each of those individual logs is. We'll do a specific example where you find a number. But what we're doing right now is we're breaking down the logarithms into simpler numbers. And the second one, we're doing division. That one goes with our second situation. So when I'm dividing, that's the same thing as subtracting the 2 individual logs. That's just the log of your numerator minus the log of your denominator. And again, just breaking those down, you don't know what 3/5 is, what the log of that is. We will, however, know what the log of 3 is, what the log of 5 is, and we'll just subtract the 2 numbers. Now the last one, we could use as the logarithm of product, because 9 is just 3 times 3, but 9 is also 3 squared. So this is the same thing as the log of 3 squared. In my opinion, this is one of the most helpful, because this makes the process a little bit easier. There is an exponent attached to my argument. That exponent comes down in front, and that is just 2 times the log of 3. So it's 2 times the log of 3. So whenever there's an exponent attached to the argument, it just comes down in front and it is a multiplier. Now, if you notice, none of these examples had a base. You know, I kept talking about base B, base B, base B. If there is not a base, it has base 10. Base 10. Okay, this is a common base. Anytime we have base 10, our calculator can do logs. If we have bases other than 10, depending on what kind of calculator we have, sometimes it can do it, sometimes it can't. So now we're going to actually use this to break down some pieces of information if you know specifics about logs. So here, I want to be able to condense this down, and I'm going to write it as a single log with a single argument. So now I'm going to go vice versa with it so that you can kind of see how does this work. In the last ones, we broke them into 2 individual logs. In this case, we're going to take those 2 logs and bring them together. Now here, I do have a base of 5. They have to have the same base in order to condense them. So when I start looking at this, I look at the fact, okay, they both have base 5. So this is log base 5. Now, I'm subtracting. There is a property that goes with subtracting. When I'm subtracting 2 individual logs, it's the same thing as dividing their arguments. So therefore, this is just log base 5 of 4. This is in condensed form. So you'll be able to take multiple different logs, condense them down into a single log, 1 log written, with a single argument, 4, instead of 12 divided by 3. So with this information, we're going to check to see what happens when we're finding specific logs along the way. I'm telling you the log of 2, the log of 3, the log of 5. Those are common logs that you'll get used to seeing when we start evaluating pieces of information. So if I want to find the log of 6, I have to rewrite the log of 6 somehow so that there's a 2, a 3, and a 5 in the argument piece. Okay, because I know the log of each of those. Now again, please don't make up your own rules. How can I get a 6? Logs, the arguments are multiplied, divided, and have exponents with 2s, 3s, and 5s. So the log of 6 is the same thing as the log of 2 times 3. Right? 2 times 3 is 6. And now I'm multiplying within my argument. So that means that's the same thing as the log of 2 plus the log of 3. And you know that the log of 2 is 0.301. And you know the log of 3 is 0.477. So you just add these 2 together. And when you add them together, you get 0.778. So that's the sum of those logs based on finding just the log of a single number 6. Next one, 25. How can I get 25 with 2's, 3's, and 5's? By multiplication, division, and exponents. It could be multiplied. But again, when we start looking at high ones being multiplied together, it's easier if you can look at an exponent. Okay? So this is just the same thing as a log of 5 squared. And if there is an exponent attached, that's the same thing as 2 times the log of 5. Log of 5 is 0.699. So that's 2 times 0.699. And 2 times 0.699 is 1.398. Now, grab your calculator out. Find your log key. Type log 6. Enter. You should be really close to 0.778. Then do log of 25. Enter. You should be really close to 1.398. So our calculator can do these because they are base 10. If it wasn't base 10, you couldn't do these. So here's another representation of what you might see. I'm telling you what the log of x is, and I'm telling you what the log of y is, and I want you to find the log of the product of x and y. Now, do not make up your own log properties. Think about what this means. You guys know something about the log of a product. So, without looking at what they gave us to begin with, in the beginning information, what can I do with this? I have the log of x times y. Well, what does that mean? Log of x times y is the log of x plus the log of y, correct? Yes? So, I'm telling you the log of x is 3. Hey, that's 3. Plus, the log of y is 5. Hey, that's 5. Evaluating that, I get 8. Be careful, common mistake is to multiply 3 and 5. Not a rule. Not a rule at all. I do not multiply 2 logs. I add 2 individual logs when I'm multiplying their arguments together. So, I want to know, are these properties? So take a moment, write yeses and nos next to them. So, can I add 2 logs? Absolutely. Can I subtract 2 logs? Yep. Is there a property that talks about multiplying 2 logs? No, not a log property. Can I multiply 2 logs? Sure, but there's no property that goes with it. Can I divide 2 logs? No property with it, but I can divide them. So please keep in mind, the first ones are properties. If you see the log of A plus the log of B, that's the same thing as the log of A times B. If you see the log of A minus the log of B, that's the same thing as the log of A over B. There is no property for the other two. You can do them, but there's no property to help you break things apart. So now that we've learned how to work with log properties, there is a really helpful way of solving this problem. So this was the first problem I had you guys work on when you evaluated logs and figured out what logs were. My exponent's my unknown. That's a log. But because of that, because that exponent is my unknown, what we can do is we can go through some different pieces of information to solve this. So, remember what I do to one side, I do to the other? I'm going to do the same thing here. I can apply the log on both sides. So I'm going to take the log of both sides. And the reason I'm going to take the log of both sides is, and I'm going to do the log base 10, because I can do that in my calculator. The reason I'm doing the log of both sides is now I have an exponent attached to my argument. And as whenever I have an exponent, that moves down in front. So I logged both sides. Legitimately can do that. Then I have an exponent attached to my argument. That exponent comes down in front. So rewriting this, it's x times the log of 3 equals the log of 10. I need to solve for x. I need to get x by itself. What's attached to x? Log of 3. The whole thing moves. So on the left-hand side is x. On the right-hand side is log of 10 over log of 3. Is there a property that talks about dividing logs? No. Nope, nope, nope. I instead just divide these in my calculator. Take the log of 10. Make sure you close that parenthesis and divide it by the log of 3. And x just equals 2.096. And we found that the other day. So please make sure that you're being careful when you're going through. You're not making up your own log properties. But now, guys, you can solve all problems that have an exponent as your unknown by taking the log on both sides. Okay. One of the best things that logs help us do is it helps us solve. Now, downfall to this problem, you have to have your calculator. There are definitely going to be some problems where you don't have to use your calculator just based on being able to rewrite it, doing some factor tree information. But for all problems, if your unknown is in your exponent, log both sides and go through the math.